All right. All right, should I just start, Amy? Okay, so I'll get going. I'll just quickly introduce myself for a second. My name is Jesse Sadler, and I am a lecturer at Loyola Marymount University. And I'm a historian, but I use R for various fun activities, but also just for analyzing some historical data. And it was in analyzing, trying to analyze a specific type of historical data, namely non-decimal currencies, that got me on this project. So what I'm going to talk about today is vectors, using the vectors package to create custom vector S3 vector classes. Okay, so first I want to, I'm going to try and go between using the slides and some RStudio stuff, so we'll see how that works. But so let me first start by going through some nomenclature, just so we know what's going on with S3 stuff. So S3 vector classes in R are sort of the most basic vector class. And basically all you need is a base type with at least a class attribute. And so that's all you need to do. You don't need to do anything else. They work through generic functions so that you can basically have the same function, like a print function, behave in different ways, whether it is a factor, a numeric vector, or whatever it is. And then they do that through implementing different methods. So you think of like the print function, it has a lot of different methods. So let me go really quickly and just look at creating an S3 class. So everyone can see this? Yeah, doing good so far? Okay, I see some head nodding. That's good. Okay, so this is the basic structure we have here. So if you just do my class, all I'm doing here is saying I want this to be numeric, and then the structure is doing it. And I'm creating a function that will create a new class called my class. So I can just do this, and all of a sudden I have X. And if you look down here, the printing method isn't very nice, but if I do my class, I have a class. So all of a sudden I've created a class. So S3 classes are super simple. Why you might want to create your own class is that you might want to create a class that has an attribute that you're interested in. So here I'm doing the same basic thing, but I'm creating a class that has an attribute called our users. And so that is a logical, and so we go like that, and then you say, yes, I heart our users, so that's true. And again, we have a basic class, and you can see we have the class, and we can also get the attribute. And so we see that the attribute is true. But when we try to combine these things, so we combine two of the my class, we basically get it a numeric vector. It doesn't do what we want it to do. So if we look at class, we get a numeric vector. We don't get our own class. And if we look at, if we subset it, again, we get a numeric vector. So basically, and if we want to make our own class, that's not what we want. So what we need to do then is start to implement a variety of different methods. So we have to be able to combine our class with C. We need a print method so that it looks a lot nicer than the print method that we have. We need a subset method, casting, to or from other classes. So numeric, making your class numeric, or making a numeric value your class, whatever it is, and things like plotting. So these are things that we need to do if we want to make an S3 class, but it's not always clear what we need to do in order to do those things. And you have to go through and deal with a lot of methods and generics and stuff like that. And it's not that easy. So if you're interested in creating your own class system, so you have an attribute that you want to attach, or a set of attributes that you want to attach to a base class, then you can use vectors. And vectors is a new-ish package that provides you with a path to creating an S3 class. So I'm just going to go over vectors really very quickly, and then I'll get into the example that I have. So the goal of the vectors package is a package that's created by RStudio and has 3 basic goals. The first is to implement type stability so that you can predict the output type when you know what the input types are. So here, this is just talking about classes. So you can predict the output class when you know the input class within a given function. Same with size stability, that you can predict the output size knowing the input sizes, that there's stability there. And then finally makes it easier to build new S3 classes. And so basically these first 2 were discussed by Hadley Wickham in his RStudio conference talk from 2019. And then this third one is what I'm going to be talking about. So there's underlying features of why vectors is a useful thing to use. But basically, I'm going to be talking about why it makes it easier to build new S3 classes. So what do you get when you use vectors? The main thing that I think is really useful is you get a clear development path. And that's what I'm going to be talking about mostly today, is that this really helps give you a nice, clear path that you can go step by step. And so that you don't have to look up all these different generics, all these different methods, and try and figure out what the heck you need to do to create an S3 class that actually does something that you want it to do. It will give you basic consistency with base R functionality because it's just going to be an S3 class. This is what it's meant to do. And it's going to integrate well with the tidyverse, and it's going to be increasingly integrated into the tidyverse. So if you've seen recently, RStudio just announced that dplyr 1.0 is going to come out in the next couple of months. And the internals for dplyr have been rewritten using the vectors package, which in turn also makes the vectors package very compatible with dplyr. So that is something that's really helpful to know. Okay, so what I'm going to do for the rest of the talk now is I'm going to talk about a package that I've created. And I talked about this at the last RStudio conference, but I'm doing it in a little bit of a different way here. And that is a package that I've created called the debvectors package, which you can see the URL here on GitHub. And that is basically a tutorial package for creating vectors, creating S3 classes through the vectors package. The debvectors is a simplified version of a package that I've been working on for a while that I never seem to get to actually get it on CRAN, called debkeepr, which it's basically ready to go on CRAN, but I just haven't done it. So you can definitely take a look at the debkeepr package, which has a little bit more functionality and is built for analysis. And then the debvectors gives a step-by-step guide that you can read in tandem with the S3 vignette from the vectors package if you're interested. Okay, so let me discuss what the example that I have. And this is always fun because this leads me to talk about history stuff. And so when I'm looking at history documents, mostly I'm looking at documents from the 16th and 17th century. I look at a lot of economic data like this. And so this is an account of looking at linen, bales of linen. And it has, if you see on the right here, prices of these different bales. So basically, these are the numbers of bales, and then these are the prices that you have here. And we have here pounds, and then shillings and pence. So these are non-decimal currencies, pounds, shillings, and pence. And then they're added up here. So the final here is 164 pounds, 5 shillings, 10 3/4 pence. So if you want to be able to replicate this and add this up, it's not easy because they're non-decimal currencies. You can't just add it up. The bases are different. You have a lot of problems. So, okay, what is the basic problem space? And think about here with this compound unit arithmetic, that what we're trying to do is be able to add up these numbers, 28 pounds, 15 shillings, 8 pence, plus 32, 8, 11, blah, 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 and getting this answer. So what is the problem space? So we have 3 separate units that make up one value. The units have non-decimal basis, and so we need to use compound arithmetic to normalize these, and the non-decimal bases differ by currency. So 20 shillings and 12 pence were the most common basis, but they're not the only ones. So what we see here is, on the left here, is basically this compound unit arithmetic, in which you add up the values one at a time. So here's the unit total, 132, 53, 35. But since there's only 12 shillings, we have to divide by 35 by 12. We get the remainder, which is 11. But then we carry forward the quotient and do the same thing again. Get a remainder, carry forward, and then we get our value. So hopefully that makes sense. All right. The key to, this is just sort of background, but the key functionality that enables me to do what I want to do here is this essentially a normalized function. So this is normalizing. This is just sort of a demonstration that this could be done. So this is normalizing a numeric vector of length 3, such as the one that we saw earlier. And basically what it's doing is remainder math. So the pence value is going to be the 3rd unit, with the remainder from 12 or whatever base it is. The shillings is going to be the shillings plus the quotient, what it was divided by, and then with the remainder of 20, and then the pounds basically does that again in a more complicated fashion. Then we do pounds, shillings, and pence, put it in the right order, and so now we can see that this gets us the number that we wanted to. That when we put in this unit total, we get the right answer. So we know that we can do something like this. Okay, so in creating a class for this, I was confronted with a couple of design principles, and basically what I chose is to create 2 different classes. One is a record style vector, which I call debLSD, that maintains the structure, the tripartite structure. 3 different values creates 1 unit, but then I also wanted a numeric vector that is essentially decimalized that I could fall back to. So let's go through this. So I want a class that maintains the tripartite structure of non-decimal currencies, right? So 3 units, 1 value. That I want it to track the basis of the shillings and pence units. So that's something that we can do with an attribute of the class. And then I want vectors with different bases to not be able to be combined, because you can't add up in a clear way, say, British pounds and American dollars. They don't just add together, so you don't want to be able to do that. So we want something that basically looks like this down here. With numeric, with debdecimal, with a numeric vector, we want a decimalized class that we can fall back to, and we want the same basic structure, same basic abilities of tracking the shillings and pence units, and that vectors with different bases can't be combined. But we also want to be able to choose what unit we're looking at. Are we looking at the pounds unit, the shillings unit, or the pence unit? And then vectors with different units can be combined, but there needs to be a clear way in which they're combined. And so we can get something that looks a little bit like this. All right, let me think. Okay, so yes, okay, sorry. Just thinking if I want to go to. So what we have then is the ability to, what we want is the ability to create these classes. And with the vectors package, there's a clear way to do this. So I've broken it into 6 different steps, and I'm not going to be able to go through all these steps obviously today, but it gives you an idea of the different things to do. Create the class, coercion and casting. I'll be focusing on these first 3, and then equality and comparison, mathematical functions, and arithmetic functions, or arithmetic operations. If your class is based on the double vector, like our debdecimal, then you don't have to do numbers 4 and 5. You get those for free. Okay, so here we have the basic structure within the first point, within the creation, that there's 7 different steps. And I think it's here, yeah. So again, I'm not going to go through all these, but I want to show you guys what the dev vectors package looks like and how it goes through this, so that if you're interested, you could go through it on your own, and I'll go over some of how it works. So here you can see, hopefully you guys can see over on the side, but basically this is how the package is structured. And so the scripts are structured so that there is, they're numbered by the different steps. And so if we look at the LSD creation step, we have these same different numbers. And so it goes through, and all of the comments are like this to try and clearly define what we're doing. So to create a new LSD object, deb LSD object, we basically do 3 different steps. So we define the function. I'm going to pull this down here so you can see more. We define the arguments. We give some checks of the different things, so make sure that the values are double vectors and that the bases are integers. And then we create it, and we do it with a new record. And what a record style vector is essentially a list of equal length vectors. So all of these vectors have to be the equal length. So this is an internal function, you can see here, that's going to help us create it, that has minimal checks. Alongside this, we have a helper function, which is the user-facing function that people are actually going to do, and it's basically the same thing. It goes through some more time-consuming checks. It casts for compatible types, so if somebody puts in integer or something like that, that's compatible with a double, so there's no problem. Same for the bases. Make sure that the length of the L, S, and D of the different units are the same, and then create the vector. Then we go through some other steps: attribute, asset, access, check the class. But I will spend a little bit of time on the format method here. So what we have with the format method is the way that it's printed. And so this basically gives a nice way in which it's printed. And so I've chosen to distinguish between the units by a colon. But I've also added a footer to it so that we have, we can know what the bases actually are of the different ones. So that's just something that's nice and easy and that you can do. So I'll give some examples of how this looks. So I'll create an object, a deb_lsd object, and I'll call it LSD. Oh, I knew I was going to do that. I need to load all these. Okay, it's a package, so I can just load them all. Now it should work. Yay. So these just have a nice printing functionality, and it tells me what the bases are. So here I decided to put bases that are different than normal 20 and 12. Same with dec. So it just shows, and here we see the unit in addition to the bases. So these are in shillings because I did the unit as shillings here. And then they work with Tibble, of course. And with Tibble, you can get this nice printout, so you can say, okay, this is an LSD object with certain bases. Here, you can, I've chosen to have it so that it says that there's, it's shillings with a certain amount of bases. Okay, so let me go back to here. All right, almost done. So what I want to do, the final thing I want to do is just show a little bit about coercion and casting. So coercion is implicit transformation of a class. Casting is explicit transformation. So this is that again, basically. So numeric, if you put in a numeric and a character, it's going to coerce to a character vector. Casting is explicitly done. So if you change something to a character, if you change something to numeric, it's not, right, the whole tidyverse versus regular things, but you get it. Okay. So with vectors, this is kind of interesting because coercion and casting is interesting because it's two sides of the same coin. So coercion looks for the common type with this function vectp_type2. And so you decide which type or class should be the result when they're all put together. Whereas casting does the actual transformation. So coercion is about design more, casting is about the actual functionality, the programmatic logic. So you build the logic of how your classes are to be converted. And then casting makes comparison between classes possible. So once you can cast, then you can compare something. So you could compare something like a deb_decimal and a deb_lsd class. So what's the workflow? Just really quickly, you basically give a boilerplate and then methods within the class and then methods with compatible classes. So the design choices for a coercion hierarchy within these classes, what I decided to do is basically take, if there's a double and a deb_decimal, it'll turn into a deb_decimal. If there's a double and a deb_decimal and a deb_lsd, it'll turn into a deb_lsd. So let's show that really quickly, and then I will be done. So I'm going to go to coercion here really quickly. And so I'm not going to go through this too much, but basically you can look at it. You can, the vignette's really good, and you can look at this again on GitHub. But this is the basic boilerplate that you use, so you don't really need to change anything here except a couple of things of what class you're dealing with. But here's something interesting. So here I want to build in this programmatic logic. Here I want a hierarchy of pence turns with a shilling will turn into a shilling, and a shilling with a pound will turn into a pound. And so this is where I'm going to say that that needs to happen, but I'm not going to do any of the logic to make that happen yet. And then we do coercion with compatible types. So double to a decimal, and then integer to a deb_decimal, and then the other way around. And they're the other way around are within it. And then if you go down, it's basically the same with deb_lsd. So let's look at casting. Here we have the same thing, a boilerplate, which again, you're not going to change much here. But here, when we do deb decimal to deb decimal, here's where we're going to have this logic. And so basically, if the units are the same, then just return the same thing. There's nothing to do. But if they're different, then you have to convert the units. And so here's just some if-else statements to do the math, basically. I always, think it's fun that I never thought I'd be doing this much math as a historian, and then you get the converted. And so this goes through and does these different ways of doing it. So cast to and from compatible types. So from deb decimal to double is nice and easy. You just use this vectors functionality. And then we can see the same thing with the deb LSD is going to be the same basic thing. And there's going to be different programmatic logic in it. So this is going from deb LSD to double. You just basically do the math. I will just show really quickly. So deb decimal to deb LSD, basically that then you have to figure out the programmatic logic of changing the different values here. But you guys can go through and look at that if you like. Okay, so just really quickly, it's not letting, it's like, okay. So let's just put it all together and then I will finish. So what we get when we do this is if we have an X and a Y, so we have our X, which is a deb LSD, and a Y, which is a decimal with a pence unit. They're both the same basis, so we can combine them in different ways. So we can combine them. If we combine it with something that we don't know how to combine it with, we get an error, and it's a nice error message here. And then we can also compare them. So even is X is 15, 12, 3 greater than 12, 94, 345, it does the normalization and we find out it's not. X and Y, and then is X equal to this value? So here we see basically you can implement the basics of base R functionality. So this takes something that is so outside of how basic functionality of R is supposed to work, and then makes it work. All right, so that is it. Here's my final slide. Basically, if you're interested in creating your own S3 class, then I think vectors is a way to do it. And there's a lot of good resources. Here are a couple of them, but definitely take a look at dev vectors because it breaks it down and it has a bit of a more complicated structure than the ones in the vectors vignettes. All right, thank you.
Thank you. We started like 3 minutes late, so we have 3 minutes for questions. If anyone has questions, and just.
Oh, I'll stop. Well, I'll wait to stop sharing.
Anyone has any questions?
I have a question here. This looks pretty like kind of generalizable, I guess. Looks cool. Did you see any other, I guess, similar packages in other languages to inform your design decisions and how you built it, or create it from scratch?
Yeah, so I know that one of the hopes of the vectors package is to make it simpler to create these. So there's a couple of them out there. I need to look. There's a list of a couple of things out there. So there are some packages that are doing this, and people are interested. So there was just the last. Here we are. This last one blog post, oh, don't do that, by Dewey Dunnington, looks at how to score cribbage hands with the vectors package. And so again, it's kind of like a total play example, but it just shows the possibilities of doing that. So there's more and more people that are doing it, and that's one of the things I'm trying to do, is that this is going to get easier and easier to integrate into base R and to the Tidyverse. Any other questions?
If not, we can pass on to Emad.
All right, I'll stop sharing my desktop.
Thanks, Jesse. That was really cool. I feel like there must be some other use cases, but one of the ones that I've been thinking about lately a lot are more related to defining distributions and then having operators and distributions, and that seems like a good use case for this.
Yeah, I mean, just real quick, like anything that you think you can add, like that you want to add an attribute to a base R class.
Yeah.
And now there's like a nice way in which you can do that.
Yeah. Awesome. Thank you.
Yeah, thanks.
Give you a round of applause. Very silent. All right, let me get started, everyone. Thank you for being here. First time doing this like coronavirus situation presentation, so bear with me. But also feel free to jump into the conversation, unmute yourself and ask a question in the middle. I don't have as many slides. I'll walk you guys through a lot more demo, and I expect a lot of questions and discussions around this. So feel free to jump in. Either type it, and Amy, you can bring those up, or if you just want to unmute and chat. Before I get started, I'll give you guys a little bit about my background. So my name is Imad Hassan. I'm engineer by training, and did engineering for a long time, building control systems for helicopters and satellites. Grew up doing mostly MATLAB. I did MATLAB for maybe like 10 years, and then transitioned over to R when I started doing data science. And mostly it was a very seamless transition, and I've come to fall in love with R. I think the ability of R to do prototyping, in my opinion, is faster than any other language that I've used, but Python users always will contradict me on that. But really, I'm a nerd like you. This is my photo with Hadley on from our studio conference. I felt like I was running around celebrities at the R Studio conference. It was a lot of fun. All right, here are some of the problems I was seeing in my life. Oh, what I didn't tell you guys is what I do now. So I run a startup called Retina out of Santa Monica, and unfortunately, what's been happening is my life is moving farther and farther away from the day-to-day data analysis. But I've still figured out a way how to use R in my day-to-day life, and I'll show you guys a little bit of that. The other part is I've now become somewhat of an expert at customer lifetime value. I do that day in, day out. And the good news is that a lot of the prior work that had been done on customer lifetime value has been done on R. So that's been really, really exciting. And if any of you have questions about that, feel free to ping me. I'll tell you all the secrets. Here are some of the problems I get asked for that I was trying to solve with that I'm going to share about today. Getting asked for the same reports over and over again, and figuring out like not just to set up a pipeline, but setting it up, pulling it up on demand. So I'll tell you guys how I address that. Does anybody use Databricks? It's a weird thing to ask over Zoom. Like, I'm not sure if you guys are going to unmute. Like, yeah, like I don't know if there are people who are that excited about Databricks that will do that. But basically, we had a really interesting need where we have a lot of our Retina employees who are working with our clients. They want to kick off they're at a client site. They want to kick off a Databricks job and get the results to them directly without having to log on to Databricks. You can call them lazy, but that was an interesting use case. Another very complicated problem. We do stand-ups every morning, And every morning we're like, who should go first? Really difficult problem. And we're like, hey, maybe there's some solution to that. I always want to pretend like I'm a big Hacker News fan and read it all the time. I don't, so I was like, how do I get to the news without actually having to go to the website? And people's birthdays at my company, I was being very lazy, so that's why I was like, let's figure out a Slack bot that uses R and uses Plumber to build this all out. And I'll show you guys a quick demo afterwards. But before I do that, let me show you what the architecture of this looks like. Is everybody following me so far? All right, great. I see a couple of heads nodding and 2 other people sleeping, but that's okay. So here's how it starts. So first of all, you write your R code and you ship your R Plumber directory remotely over to DigitalOcean. Then somebody decides to do a / command on their Slack terminal, which then will basically go over to the Slack API. Slack API will then ping your host, your host where you've been hosting your R Plumber code, and that then kicks off a job or some sort of a response. The DigitalOcean server or R Plumber will respond with the JSON that gets interpreted by Slack and shows up on your computer. All right, enough presentation time. Let's do some demo. Let's see if I can pull this up. So I was just testing this before, but let me show you guys. All right, so here's a little demo. I'm on usually every morning when we come to, so first of all, our bot that we are going to be using is called Tina, short for Retina. Tina order. If I do this, it does a very simple command, which is it will list out in a random order all of my team members. And that's how we do our stand-up. We'll go through our stand-ups. This is a very, very simple functionality. Another one I told you guys about is people's birthdays. So we have a little database set up anytime somebody new joins, along with our holidays. All of our holidays are listed here, and people's birthdays that are coming up, it'll have a little like thing. It also has a functionality that I've built where is there a cron job. So like on the day of the birthday, or like if a holiday is coming up, it will pop up on people's Slack on our general channel and do that. No data science yet, but now let me show you guys a little data science scenario. So we also have our Trello board and tasks for people on our Trello. We've actually, did I have a question? Finally, please, yes? No? All right, no question.
Not sure.
All right, well, I'll get started on this. All right, so another component is this data science component where we basically want to analyze how our work in progress is looking. And for that, we connected that DigitalOcean to the Trello app through that API. And now I can kind of pull up, if I do Tina Trello, I can have, let's see, did that start? Yep, so that just kicked off a job. And now it's going to go run that whole analysis, pull out all the data sets, come up with a work in progress, pull up a ggplot and show me who's working on what. So you can kind of see all of that. This is a little bit outdated because we've moved away from Trello. We now use Jira. I never ended up building a Jira version of this bot, but let me show you another version of this where we have built this out for a client where if they do /retina, they can click on a customer and look up a data. So in this case, DigitalOcean is connected to a database and they can pull data directly for a customer. So if I put in the customer ID, hit send, now it's gonna go pull up all the customer data for this demo customer. Don't worry, it's not a real customer, but just wanted to show you guys like this ability to run ggplots and analysis in the background, pull up the data right in Slack. So these are some of the cool things we're able to do once you've kind of set up this infrastructure. And right after this last demo that I'm going to show you, I'll show you how you can actually build this. And it's actually fairly straightforward to do. Took me a while to get this going, but I've documented everything as I put this together. And if you guys are interested in doing this, I'll show you. So TinaDB is another cool part, the cool thing that we do internally. So TinaDB is the Tina's ability to run Databricks jobs. So if I pull this, the first thing it will do is it will go and like find all of the jobs that are available to be run on Slack. So here are all the names. I'll pick one of the test ones. So run test job. That's the one I want to run. So now I'm going to do TinaDB run test job. What it'll do is it will go ping the Databricks API and pull up all the parameters that are required to run this job. I can click on this and go to the Databricks instance of like actual API. If I want to run that job remotely from here from my Slack, I can just go and like put in the numbers, and then in the background, it's all running on our plumber. Let's say I hit send, it kicks off the job, and it will take about a minute maybe, or like 30 seconds to go run this job. And all it's going to do is it's going to concatenate these two fields, or I think add up the first two, concatenate the second. This is just a test job. So it's running in the background. Once it comes back, what's also really cool about this is that it's going to spit out any attachments that were generated by that job will also be spit out in Slack. So think about like the big problem of security. Anytime you have any kind of a data science job that spits out a report, typically like you cannot like directly put it on a link because there are security issues, right? But here, since we're sending it directly to Slack, I can just download the file that was generated by this right here, and all of the security of Slack is enabling me to do that. Any questions so far? All right. So let's take a look at how all this gets done. So let me pull up this. So really all you need is 3 packages. You need to have a Slack account, and you can create a Slack bot directly on the Slack app directory. So if you guys are an admin of a Slack, or you can create your own Slack channel, you can create a bot. So this is the Tina bot that we were looking at. All you need is this client secret and signing secret that's going to go into our plumber. And then what you need on top of it, actually, do I have some questions here? No, no questions yet. If you go to our plumber, has anybody used our plumber here before for anything? Okay, this is the coolest package that I've seen since 2003. No, I'm just kidding. There's been tidy worse since then. That's definitely cooler than this. All right, our plumber is a really cool package because it basically takes your R files and converts them into an API, converts it into an API, a REST API, which you can interact with JSON. Essentially, you throw it onto any kind of server, and all of a sudden your R code turns into a live app, web app. In this function, typically, the way that it's set up is you have routing and endpoints. If somebody goes to a website where your code is hosted, it knows how to route it to the right R functions. So we'll write a quick function here, and I'll walk you guys through what that looks and feels like in our plumber. So I have an example of that, and we'll quickly walk through that. All right. So first thing you need is in the R plumber script is strange in a sense that you in the appending in the initial like comment section, you kind of put together how you want that app to respond. So if the Slack called is /user demo, then I am going to have this function get run. This is that routing that's getting done. After that, there is a small section here that does Slack authentication requests, so that not any random person can just go to the IP address of my bot and pull this code, try to get it to respond. So there's some really good authentication built in already. And then you basically have a JSON response that you can respond to with that for that command. This is written out in list form. That's how obviously it's easiest in R to write this stuff. But what this is very specific this format is very specific to the Slack documentation on how Slack wants the response for it to go put it into a pretty message. So if you look at it, all it is response type is ephemeral, which means it will disappear after a while. So if you guys have used Slack, you can see how how like there's some messages that are only visible to you and not the whole channel. So this is one of those types. And then we attach basically a simple text and a link to it, which will take us to some HTML to a website from our Slack. Now, how easy is this to deploy? I save this. I go to my deploy script. In the deploy script, I connect to my DigitalOcean, and then I have a bunch of like pre-flight commands that are basically taking my tokens that are, or not tokens, or my environment variables from my local machine and posting those to the DigitalOcean server, and then it's rewriting, essentially that's shipping that code over to the DigitalOcean side, and that takes maybe a minute. So once this is done, you should be able to go to Slack and do /Tina user demo, and that created that little quick link demo. Click that button, takes me to that HTML that I had in my R code. Right, went through. I'll pause here. Nobody asked me any questions, so I'm assuming that everybody's either sleeping or this was somewhat interesting.
Can you, I'm not familiar with DigitalOcean, and why did you choose to use that?
Really good question. So I did a ton of like research on how to set this up. And one thing I did not cover is how do you do this? So I basically wrote out a very detailed guide on how to do this. If any of you want to do this, it took me like maybe like 3 weeks to figure out all the existing blogs that were out there about Plumber and Slack documentation that kind of had to get combined. The reason I used DigitalOcean is because the analog C package that ships over the code to the server is very cleanly written, so that I don't have to like write my own SSH scripts to ship over the code. So that's why I ended up choosing DigitalOcean, but you don't need to. You could probably set up a EC2 instance and set it up there, set up all the permissions yourself. So there's no actual need to be using DigitalOcean. It's just one that I ended up choosing and that I found to be easy to use. There is a problem with DigitalOcean that you have to pay $5 a month to keep it alive. But I suppose that you'd probably have to do that with any other server that you end up choosing. One thing that I wanted to cover is, so in this blog post, I also have a link to a Git repository, so you can download all of the sample scripts that I used, and there's a demo in here that you can try out yourself. It covers all of the issues you might run into in terms of like setting up your SSH. It has screenshots of how you want everything to look as you're setting up your Slack app, and anything else. Oh yeah, any configurations you might have to put in place. The biggest issue was like, do you put an ending slash or not when you set up your like default URLs? Like it took me like a day to figure out that was a bug, that like nothing was getting reported. But yeah, besides that, I think it should be fairly easy to do. It's the easiest way for any of you guys who are working in any corporation to look like a hero. If you can go figure out a way to set this up and just run it, you're gonna look like a rock star.
There is one question in the chat.
All right, let me look for it.
I can just ask it. So like,
yeah,
does
please.
our Plumber essentially just like allow for like basically to quickly host a web app? And if so, like, do you think it'd be possible to like deploy a Flask app via Elastic Beanstalk and then use that?
Absolutely, exactly. That's why I don't like Python guys, because they're like, oh, let's just do a Flask app. No, you want to do R.
All right.
I have another question. There's
Yeah.
also a package called Slack-R.
Yep.
I know your app can probably do more than that, but how do you also use that package, or do you?
Yeah, Slack-R is really cool because you can use it to like from any script you can send messages to Slack. I don't remember it having the functionality to like interact in both directions. So I spoke with the author of it at the 2019 RStudio conference, and basically he mentioned that those are some capabilities that can be built. And we were like, oh yeah, it'd be really cool to have a app that could just automatically deploy all this, or a package that could do all this. So certainly something that if anybody wants to work on, there's somebody. It's probably be a cool package or addition to Slack-R. Yeah. Dedicated data. How much? So there's a question Andrew is asking. How much infrastructure do you need to build underneath the app, or is most of the processing happening on the fly? Yeah, really good question. So there are two types of data processing that. So Slack has a really interesting rule that every response must come back in 3 seconds, and if it doesn't come back in 3 seconds, you must set up some sort of an asynchronous process that will come back from wherever it needs to do whatever processing and can respond to that message. So typically what we do is we will send an acknowledge message saying, all right, we've kicked off a job for your Databricks. Now it will respond whenever that job is done, and then we'll leave like some sort of there's essentially a Slack message token that like sits with the Databricks job, that whenever that job gets done, it will then send that back over. Now, good news about Databricks is that it also has an API, which is fairly cleanly written, so that you can run all of this through that API. All of this will require essentially a simple understanding of how REST APIs work and a little bit of like getting used to rplumber. All right, any other outstanding? Oh, there's one more. No, that's it. Cool.
I had a question.
Yeah, go ahead.
Hi. So I was just curious. I know with something like Shiny, there's the capability of sort of directly publishing your app from the RStudio interface. Does Plumber have anything like that to be able to sort of directly publish that code to some server somewhere?
Yeah. So you know, shinyapps.io has some sort of a capability that it looks like it could do rplumber, but no documentation says it supports it, and when I tried it, it did not work. I already actually have a account with shinyapps.io, and unfortunately I wasn't able to deploy it right away. So this is something I suspect that if I'd like reached out to the RStudio folks, they might have some insight on it, but I wasn't able to do it. Yeah, drop me a line if anybody wants to try this out. I'm super excited about like enabling Slack to do all these data sciencey things because it enables our stakeholders who might be down the road, either analysts or even folks who like just want to consume reports. I think rShiny is really cool. I'm a big fan of rShiny, but it's not as mobile friendly. So if I think about like executives who are generally either on email or are on Slack, I think this is a really cool way to surface insights and reports to them without actually having them get on their desktop and pull up the reports. They can kind of just do it directly on your phone.
Do you are your customers also on your Slack, or how do they use the app?
Yeah, really good question. So we built out the Slack app thinking that we would basically, so we used to have a portal where we would have all these dashboards and we would want our customers to go and use our dashboards. But the truth is, like, getting people to like go to a website and log in is like a brand new habit you get them to try to build. It's much harder. then to tell them, hey, just go to /Retina whenever you need anything from us, and it will basically pop up on your Slack. And whenever they think about lifetime value, they can kind of easily do it. So it's a lot more easier for us to deploy stuff directly for our clients than it is to like get them to log into a brand new app.
If there is no more question, we'll give some air claps to Iman.
Thank you, everybody. We appreciate it.
Yeah.
Thank you.
Yeah. Again, we'll be hosting online meetup again in April and May, and I'm right now figuring out how to have a virtual social hour, most likely on Zoom. And feel free to Slack me or other organizers if you want to be a speaker or if you want to just get involved in general. Have a good night, everybody. Oh, I'm gonna open this Zoom for a little more, and if you guys want to chat, but we'll close it later. And have a good night.
Thanks, everybody.
Thanks, Amy. Thanks, everybody.
Thank you.
Thanks, Amy. Thanks, everyone.